Yeah, you're on a separate piece of paper. So we're going to do some set theory review because your test is on Wednesday. So set theory review, then we're going to do some probability. Set theory review, probability. That's what the next 2 days are going to be. So let's go. So this one here, it says Venn diagram to show these sets. You're going to draw one on the side on a separate sheet of paper, the universal set. I don't care if you write these questions down. I just want you to do the questions, okay? They don't need to be written down. This is just practice. So you're going to draw a Venn diagram representing these. The universal set is the integers, so not decimals, from -10 to 10 inclusive. N represents all those. P represents all those. E represents even numbers greater than 0 and less than 5. And you have to figure out which ones overlap, right, when you go to draw the Venn diagram. Okay, so try that out. We're just going to draw the Venn diagram. We're not going to do anything else yet. You can list the elements if you want first. That's what I would do. I would list the elements for B first, and then we're going to draw the Venn diagram. So we're going to list the elements in each set first. So the universal set starts at what number?
1.
Negative 10. 5, -4, -3, -2, -1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now n is -10 to -1. Integers, -10, -9, -8, -7, -6, -5, -4, -3, -2, -1. No, get out paper. Uh-huh.
Ask for a pencil.
No, you didn't. So P has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And E, okay, so 2, 4, and that's it. Now, are any of these disjoint? Which ones are disjoint?
N and P and N and E.
N and E? And what? N and P? So, are there any that actually, when we put them together, give us something? E and P equal 2, 4, correct? So when we go to draw our circles, we can figure this out. N and E are not going to overlap. N and P are not going to overlap. E and P do. So I'm going to draw the E and the P first, overlapping. They overlap. We know they overlap, and we know that they have 2 and 4 in them. Then we have to ask ourselves N. Does N overlap with either of those? Nope, so it's a floating circle. I really shouldn't have drawn it that small. I don't know how I'm going to fit the numbers into it. Bless you. Okay, so you could not do this on -10, -9, -8, -7, -6. Don't do this like this on a diploma. Write it bigger. -4, -3, -2, -1. Boom. Conquered. Okay. Then for E, do we have anything in that only E spot? No, because we already covered the 2 and the 4 that are in E, right? So can we actually have an empty spot, not filled in, and put nothing in it? Yep, you can. And then the P, we have 1, 3, 5, 6, 7, 8, 9, 10. Now, am I done? No, what am I missing? What's in the universal set? Everything. Is there anything that I haven't listed yet?
0.
0. The box represents the universal set, correct? So, though it doesn't fit in those 3 circles, it's the number 0. Yep.
Can you go over how you dissected those equations at the top, or like how you got the sets?
How I broke them down?
Yeah.
Sure. So, n is the integers. Integers are just not decimals. From -10 to -1. So -10 all the way to -1, all the whole, like the numbers that don't have decimals.
Oh, so you just use the numbers. Don't just ignore the symbols, just use the numbers. Well, the
Well,
symbols I think
mean that.
do.
Yeah, because x is greater than or equal to -10, and x is less than or equal to -1, so it's the number sandwiched in between.
Okay.
And whenever you have, I always say loser, loser, because they make two L's. If you have two L's in here, or inequality signs, they're really actually called, if they're both facing L, then it's just the numbers in between. That's all it means. It's the fancy way of showing in between them and inclusive of them. Okay. Is any set a subset of the other sets? Is any set completely engulfed in another set? Yeah, which one? E is a subset of P because every element in E, which is 2, 4, is found in P, which is 1, 2, 3, 4, 5. And then I would go so much as to do this. To show that both of those are in it. Okay? Is not P equal to N? Trick question. It's not. Why? Because it's 0. Exactly. Yeah, you sent it to her. It's like ventriloquist sending. Very good. Okay. So, no, because not P, not P actually equals N. I shouldn't write it that way. Not P equals all the elements in N and 0. Right? So it's not a complement of it. Complement means completely everything else that's not in it. But we have that 0, which makes it a problem. Okay? So, went through that. Now this is the key thing here. I'll let you write that. We're going to deal with this Venn diagram. It's a two-circle Venn diagram between A and B. The universal set encompasses all those numbers, right? A is everything in A. B is everything in the B circle. This little eyeball shape is what's in A and B. What's in both circles, the whole snowman, is A or B, right? Just remembering what that means. Now, each number is in the Venn diagram as an element. So it's not how many elements, it's a specific element. Like 2 is an element, 4 is an element, 6 is an element. Because sometimes they have just the number 8, and that means there's 8 people in there, right? Totally different. Now here it says, how many elements are in the following? I put this little n. Did I actually need to put the little n? If I said, how many elements are in the following sets? No, that n is overkill. I just put it to prove a point. But I did not need to put the little n in front of all of these because I'm asking you for the number of elements in. I'm not asking for what the elements are. So do I need the squiggly brackets? No, the squiggly brackets are what you use when I say set A equals. And then you'd say set A equals 2, 4, 6, 8, 10, 12, 14, right? In the squiggly brackets. But did I ask for set A? I said the number of elements in A. So how many is there? Okay, now I want you to do elements in B. Don't shout it out. You just write it down. Yeah.
Do we like lose marks if we write out like set A?
Yeah, because that's not what I asked you for.
No, but like we write it out and then we write like is equal to 7.
You'd have to say the number of elements is equal to, or you'd have to say n of A equals 7.
Well, then just to do the word sentence.
You can absolutely do that if you go A equals and then list them all.
Yeah. Like
Yep,
if it's
totally
off to the
good.
side.
Yep.
Okay.
No, that's totally fine. That's good.
Yeah.
But you have to end with this. Yep. Because then you won't miss any. Yeah. It's true. Okay. Shh. Yeah. Okay, n of B. Quiet. How many are in B? 2. Because we count the 14 and the 7. Okay, C. What is this symbol? And is what shape in this Venn diagram?
Eyeball.
It's the eyeball. How many are there?
14, which equals 1.
D. Remember when I give you the not outside? Don't change that, right? That's the easy way to use it. Use it that way. That one's easy. Because what do? I say A or B is what shape? The snowman. And I want what? Not in the snowman. So I'm going to count everything that's not in the snowman. So how many are there? 1, 2, 3, 4, 5, 6, 7. I'm going to give you a side one. Do this one. Try that one out. I told you when they're both negated, rewrite it with the negation outside, and what happens? You flip the symbol. So I'm going to get N, A, and B, not. So what do I actually want? How many are not in the what shape?
Eyeball.
The eyeball. So there's 7 already, 8, 9, 10, 11, 12, 13, 14. I thought you meant the element 14. You were correct.
That was a lucky
There were a few people who said 1 and 7. They were not correct. Okay. N in the universal set. How many are in the universal set? 15. Because there was 14 and I was only missing one element. Exactly. Okay? So does that make sense? How you have to look, and when they're both negated, you actually have to write it outside of it? Okay. Why would I give this question? Consider the following sets. X is less than or equal to 12. X is a prime number. Why would I give this? What word is here? Prime number. What is the first prime number? I've tried to drill this home, but some people not following me. 2. Then what? 3. Then what? 5, 7, 11, and then I stop. What is the not the opposite? What's another word, not prime, but what's the other one? Do you remember? Composite. Composite, still 1 is not a composite number, right? 1 is neither prime nor composite. So that other word is composite, and it comes up sometimes. I drill prime home, and I don't drill composite home enough. So composite is all the ones where there's more than 2 factors. Yep.
Wow, why did you go to 12? It says greater or equal.
12 is not a prime number.
No, what's that 12 for?
For you to decide to figure out if it's a prime number or not.
Oh.
That's how they're testing you. Okay. Then 1 to 10, X is even. So I don't use the 1 because 1 is not even. It also is not inclusive to it. So even if 1 wasn't even, I wouldn't be allowed to use it, right? Because it's not equal to. So I have 2, 4, 6, 8. Can I include 10?
Yes,
Why?
it says lesser than or equal to.
There's that equal to sign. Yeah. Okay, you draw the Venn diagram. How would we do this? N of A or B. Would I need to draw a Venn diagram?
Yes.
Is this a plain old, like, how many are in both situation? Yeah, do I always have to draw Venn diagrams? No, when we did this question, we didn't draw Venn diagrams way back in the day. So if it's just the number that are in A or B, let's just list first what's in A or B, because that is helpful. So A or B means if it's in A or it's in B, I list it. If it's in both, I still list it, but I list it once. So it's going to be 2, 3, 4, 5, 6, 7, 8, 10, 11. How many is that? 4, 8, 9. So N of A or B equals 9. Do you see how I have the squiggly brackets around the A or B one, but I don't around the 9? If I put squiggly brackets around the 9, you're wrong. Because then you're saying the number of elements in A or B is the actual element 9. The moment you put the squiggly brackets, you're meaning the element is 9. Okay, which is not true. Okay, you guys try this one out. So I told you specifically that this happens almost on every diploma, I would guess. I'm not sure. But if I were a guessing person, this is what I would put on a diploma. I would put on a question where I don't give you the and. So I'm guessing I probably am giving you one on your unit test because I make that. I'm guessing the diploma would put them on because this is one where it actually makes sense to see, do you actually know how to run a 2-circle Venn diagram, right? If you're given all the information like the and, you just subtract, or the onlys you don't subtract. Those are more straightforward. This is more of an understanding question. Do you actually understand what they're giving you? So here it says a telephone company surveyed 96 people about their telephone use, so the 96 people total, and I told you I have to give you a total. That's one thing I have to give you. If I don't give you and, I have to give you a total. I also told you I have to give you each one separately, right? So here, 84 people used a cell phone, 68 people used a landline, right? I didn't say use a landline only, because then it wouldn't work. I have to give you each separately. The fourth thing, so I have to give you 3 things. I have to give you total, I have to give you each thing separately, and I have to give you the people who were in neither, right? So this one says all 96 people use a telephone. A landline and cell phone are telephones. Landline is your home phone. Cell phone is your cell phone, right? So they're a telephone. So I'm telling you there's 96 people total, and all 96 use a telephone. So I indirectly told you how many are in neither. 0. So I have to give you 4 things in order to find and. I have to give you the total, I have to give you each separately, and I have to give you the neither. In this case, I just told you the neither was 0. What do we do then? We add up both of them, we add up the neither, and we subtract the total. Okay? So we need the 4 things so we can take the other 3 things and subtract from our total. If we don't have 4 things, we can't find the and. There must be some other way. Okay? But if they give you the 4 things, we can find the and. So let's add them up. We go 84 plus 68 plus 0. I'm putting the 0 here just to prove a point, not that it's going to change anything. So we get 12, and then 14 plus 1 is 15. We have 152. But how many people are there only? 96. So we go 152 people, put in those, that's like what I told you when they put a ticket in for each, right? So 152 tickets are in this hat that they threw it in, but there's 96 people, so I subtract off 96, and I end up with 56. We agree? So that's 56 that have overlapped. That's 56 who put in 2 tickets, right? So how many are in both? 56. And I would be done. I want you guys to do the Venn diagram just for practice though, okay? So I would go and I would do my 2 circles overlapping. And why do I want you to do this for practice? Because this is the more straightforward question. How many are in both? But the other questions I could ask that aren't as straightforward would be how many people use a cell phone only? Or how many people use a landline only? So then I would actually have to draw the Venn diagram, right? Because the only means indirectly I have to find the and, but I'm not directly telling you you have to find it. So how have I made the question harder? By asking for cell phone only or landline only, but not hinting to you you have to find the and first. Okay? So this question is easier than that one, because this one actually tells you I need to find the and. So we put our 56 in here. We have cell phone and landline. We do 84 minus 56, and that's what? And then we do 68 minus 56, and that's? And how many are on the outside? None. So if I said cell phone only, you would tell me it's 28. If I said landline only, it would be 12. But I still have to find the and first, right? So remember that. When I ask for cell phone only or landline only, I'm making you find the and without saying, hey, you have to find the and. All right? Okay. And like I said, you need to know how to do these. Maybe not even for the diploma, but I know for a fact my unit test has it because, well, I read it. So there's that. Yeah? Yeah. Okay, you guys try this one out. The campers at a summer camp were asked to choose an activity. 28 campers wanted to go canoeing. 45 wanted to go swimming. 20 campers wanted to do both. 11 wanted to do neither. Okay, 2-circle or 3-circle Venn diagram, Elizabeth? 2. Wow, you threw your voice and became masculine for a second. That's crazy. So, yes. So it would be full. So we have 2. And then we draw our 2 circles. And we have canoeing and we have swimming. Hunter, where do we have to start at? The middle. How many are in middle? 20. Landon, for S, how do I figure out just swimming?
Minus the poles from the swimming.
Right. So it's 25. When wouldn't I subtract them? Yeah. So if it's said swimming only, or the other way they can weirdly word it is swimming but not canoeing, right? So swimming only is the same as swimming but not canoeing, which is a weird way of saying it, but it's the same thing. Okay. Canoeing. Caccione. How?
You subtract 28 from 20.
Right. So you take your 20 and you take it away from the 28 and you get 8. And then we have 11 that are out in the outside. How many campers were at the camp, Alyssa?
64.
How'd you do that? Right. And you remember to add up the 11 on the outside, which some people forget. Now, I could have said, how many do canoeing or swimming? What would we add up? Bless you. 8, 20, and 25, the snowman. If I said how many, and they already gave you that. But, yeah, we went over to everything else. Never mind, we will move on. Okay. Another question. The owner of an ice cream parlor surveyed 60 people as they left. And if I were you and you were me, I would be highlighting, because all of this is words and words and words, right? I highlight important information, and then I label it like total or only or this or that, right? Because highlighting is where it's at in math, because that's what helps you. So we surveyed 60 people as they left. 34 people liked vanilla or had vanilla. 28 had chocolate sauce on their ice cream. 13 people had neither vanilla ice cream nor chocolate sauce. How many people had vanilla ice cream and chocolate sauce? So how many circle Venn diagrams is this? 2. And what am I making you find? The middle. So the owner of the ice cream parlor is 60 people as they left. So that's the what? The total. So that's one option I need. Then 38 people have vanilla ice cream. That's another thing I need. Chocolate sauce, another thing I need. Neither, another thing I need, right? So if I have all 4 items, I can find the and, correct? So I'm going to go 34 plus 28 plus 13, and I get 15. 3, 4, 5, 6, 7?
Yeah.
75? Just added them. What?
Sorry, I thought you were doing like. Never mind.
So 75 tickets were put in the hat, and there's 60 people, so I have 15.
See, I thought you were doing that equation and you got 75 for it. And I was like, okay. And then I looked up.
If you write it down like V and then the and symbol, then C equals 15.
You would have to say let vanilla equal B, let chocolate sauce equal C.
Yeah.
So you would have to literally tell them what the variables stand for.
Why the variables are on the Venn diagram?
Yeah, but you drew the Venn diagram, my friend. They didn't. All right. So, moving on. Here's your 3 circle, and then we're going to move on to some probability. Do the 3 circle. So, we're going to go through, and we have physics,
Hold up, I'm not done yet.
chemistry, biology. Now, this is the most basic 3-circle Venn diagram I could give you, correct? It all just nicely fits together. There's still ones like this on a test you guys will get wrong. So these are the ones that should not be getting, that you should not be getting wrong. So we start off with the all 3 sciences, which is 12, and we put it in the middle. Then it says 33 students took chemistry and bio. So I have to go to the chemistry and bio eyeball, which is this. And in this eyeball, I should have 33. I already have 12. So how many should I have here? 21. So that's 21 people who took chemistry and biology only. Or I could say 21 people took chemistry, biology, and not physics, right? That would be another way they could say it. So if it's just straight up took chem and bio, it's the eyeball. And you have to remember to subtract. Now, we finished that one, we finished that one. Then we have to go to another and. We always have to do the ands next. So 15 took physics and bio. So physics and bio is here. There's already 12 in that eyeball, so I need 3. Then we do 27 took physics and chemistry. So I need 27 in here. There's already 12. 15 would make 27. Then we always have to do the singles, and the ors are last, right? Because they're the two circles that are together. We have to do the ors last if there are ors. This one is so nice, I basically didn't even give you an or, right? This is the nicest 3-circle Venn I could have given you. So, and this is the key thing that wasn't written. So it says we're required to take at least one of physics, chem, or bio. So there's no one who could have taken none of the 3, right? So we have 68 took bio. So in this circle, I need to have 68. How many took only bio?
32.
Because I subtract these 3 numbers, right? Then I need to have 62 took chemistry. So in this circle, I need to have 62. I already have how much? 48. So how much do I have in just chemistry? 14. And then in just physics? 7. When I add them all up, how many do I have?
104.
So that's the nicest 3-circle that I could give you. Yep.
So how would you mark that on a test?
You'd mark it on your Venn diagram.
So you'd like go through every section?
Yep.
And so this one question would be worth 1, 2, 3.
No, they'd be worth like 0.5s or 0.25s. Yeah.
And is that 0?
This question would probably be out of 2. Yeah, then the 0 is necessary.
You have to put the 0?
Yep. Yep. To show that there's nothing there. Okay? So now what we're going to do is we're going to review the probability that we went over so far. So what probabilities we've went over so far is just plain old probability. We went over odds, correct? And we went over perms and comps probability. All we have left is mutually exclusive and not mutually exclusive, and independent and dependent. That's it, which is 2 lessons. That's all we have left in probability. Okay, just 2 lessons. That's it. So mutually exclusive and not mutually exclusive we're doing tomorrow, and then independent, dependent the next day. Okay, so we're going to review what we've done so far in probability so that we know what we're doing. So if I gave you odds, so this is review for this, odds in favor of winning the Stanley Cup are 4 to 1. Okay, that's just my statement. So my statement is odds in favor of winning the Stanley Cup are 4 to 1. Okay, pretty good odds, yeah, because it's odds in favor, which is productive, right? So before I ask you any questions, before you even do any questions, the very first thing you're going to do is label your odds. There's 3 things you need to label on it, and then we move on to questions and we can answer every question perfectly, okay? So if it says odds in favor, that means whatever I say after comes first. So odds in favor of winning the Stanley Cup. So this is going to be winning. This is going to be not winning. So winning is 4. Not winning is 5. That's 1. Got ahead of myself. Total is 5. So from odds, we can always get 3 things. We can get not winning, winning, total. Right? Okay. Now I can ask you any questions. So I want the probability of winning. Whenever we have probabilities, as a reminder, we do probability of winning. We write it as P of winning. We can write a W for now, but if this is a test, I wouldn't want to short form anything. So if at any point in time you're short forming, think Only thing in short form is the P or the little N's here, right? I would have to write the whole thing out. We don't want a short form, especially on a diploma. We don't want them guessing at all or thinking that we're assuming something, because that's not good. So probability of winning is always the number of winning. You always write the word on the top over the number of what? Total. Because I labeled my odds, because I took the few seconds to label my odds, which is all it takes, that extra few seconds, I won't get this wrong. So what is it going to be? Winning is
4
out of 5. Now what if I say to the nearest hundredth? Determine the probability to the nearest hundredth. Go. Everyone trying it out. Probability to the nearest hundredth. Go do it. 100. And that's not right. What part of sh are you not understanding? The sh or the part of it, or the. Okay. So we're going to go 4 divided by 5 in our calculator. We agree? And then in our calculator, it's going to give us 0.8. And we're really going to just want to write 0.8. But that's to the nearest tenth. Because remember I told you decimals are based on how many zeros the number has, right? So if I say tenth, a 10 has 1 0, that's 1 decimal place. I say hundredth, 100 has 2 decimals, so 2 decimal places. A thousandth has 3 zeros, 3 decimal places. It's totally based on your zeros, right? So I want to the nearest hundredth. So 0.8 is what it shows on my calculator, but that's to the nearest tenth. So I have to add a 0. If I say to the nearest whole percent, I have to take that, times it by 100, and I would get 80%. So if it says percent, remember to multiply by 100. 100. I don't know why I add this one. Or 10 times 10. Yep, that works. Okay. Now I want the odds against not winning. Writing this question out. Odds against not winning. So if it says odds against, then it comes second, whatever is written after it. We agree? So if it says odds against not winning comes second, winning comes first, which looks a heck of a lot like this. So it's the same, 4-1. Okay? I'm going to give you a question. Odds against rain tomorrow. Huh? Well, you're going to find out, I guess. Odds against rain tomorrow. Odds against rain tomorrow is 3 to 7. I want the probability will not rain. Tomorrow. So the first thing we have to do is label, right? So we have odds against, so whatever comes after that comes second. So odds against rain. So rain comes second. Not rain would come first. And with my odds, I always write the total. I always do 3 labels. Okay? Now, if it says probability it will not rain, it's going to equal the number of not rain amounts over the number of total. So it not rains 3 out of how many? 10. Guess what other answer I'm going to have on the test? 3 out of 7. So if you don't know that odds add up to total, you're going to pick the oopsie every time. And you might be like, nah, I'm never going to do that. It gets picked sometimes more than the correct answer, okay? So we don't want that to happen. So remember, probability is always over total. Okay. 3. I'm only going to give a couple minutes for this, and then we're going to do a perms and comms probability. So probability, the sun will shine, meaning it's not cloudy. Will be, the probability the sun will shine is 0.80. Determine the odds in favor of the sun shining. What do I need my probability to be in order to do odds? A fraction. What's 0.8 as a fraction? 4 out of 5. So it would be 8 out of 10, which is correct, or 80 out of 100, or reduced to 4 out of 5. Remember, your calculator is nice and will do it for you. So we know that the probability of the sun shining is 4 out of 5. So you try the question. You have a minute. So when we have probability, we can still label, correct? So the bottom is always the what? The total. The top is the number of what? Sun shining, right? So what's the not sun shining? 1. Because it needs to add up to the total, correct? So we can pull all of our numbers off of a probability. We can pull all of our numbers off of an odds. We just need to know which represents what. Okay? Now I want odds in favor, so whatever comes after it comes first, of the sun shining. So sun shining first, not sun shining second, the sun shines 4, the not sun shines 1. 4 to 1. Okay? Not a hard question. If you know how to label. If you can't label, hard question. Okay. Number 4, probability question. There are 6 principles and 20 teachers to form a 6-person subcommittee. At this point, I can go two ways with this. I can just full out ask a permutation question, or I can turn this to a probability permutation question. How do I do that? Write the word probability in it. That's it. That's all I'd have to change. So I can go, there are 6 principals, 20 teachers to form a 6-person subcommittee. And then I could say, determine the number of ways the subcommittee can have 2 principals. That's a plain old permutation question, right? Or I can say, determine the probability the subcommittee has exactly 2 principles. How does that change the situation? We do the situation the exact same, it just goes on the top, right? And then we divide by total no restrictions. That's the only difference with the word probability. That's it. That's all it changes. People get so overwhelmed with these. They're not overwhelming. They're only overwhelming if you don't know your perms and comms questions. But it's literally just the perm and com question on the top divided by total no restrictions. Okay? So let's think about this. It says, determine the probability the subcommittee has exactly 2 principles. Now, after, the word probability affects the top, correct? So on the top, I need to have 2 principles. Now people will think that's all I need. But we need to go through, and this is why highlighting is so important, or underlining. There are 6 principals and 20 teachers, which indirectly gives me 26 people. And I always on a probability question want to write the total. Because I'm going to be using that total in my denominator every single time, right? To form this is the key thing, every single time we did perms and cons, a 6-person subcommittee. I don't know why you're packing up, because I'm still going through this question, so unpack. It's going to be fun for you. So, especially since there's, a lot of time left. It ends at 45. Okay. Oh, even better. I'm finishing this. So, we have 6. 45 is the 3rd period. Still not used to this. So we have 6, choose 2. Why is it a C? No jobs. And then I need, 4 teachers. Why do we need 4 teachers? It has to be a 6-person subcommittee. And means I multiply 20, C, 4. Right? That's how I would have done the question before. Now I just need to do no restrictions on the bottom. How many are there? 26. And I need to choose 6. That's it.